All right, so now we are going to look at RGB images, and we know that what a grayscale image is. So a grayscale image is nothing but a grid of images, right? You remember grid of numbers? So that was some image that has rows and columns in it, right? So suppose there are R rows and C columns in total, right? And we have a total of R into C number of pixels in that image, in that grid, right? For grayscale image, we know that the values vary from 0 to 255, right? And 0 represents white. Oh, 0 represents black, sorry. It is black color, and 255 is actually the whitest of the white, the pure white. So that was a little bit about grayscale images that we just saw, and then there was their representation and different pixel values that they have. In the same way, an RGB image has um, three rows, right? Oh, sorry, three channels, right? And they're stacked on top of one another. So this first one is responsible for representing all the intensities of red color, right? And the second one on top of it represents the green intensities in that image, right? So we have two channels stacked on top of another, or two bands, or two grids, which are basically matrices that we call in the programming paradigms. And then we have the last channel, that is blue channel, stacked right on top of another. So they are the three bands that we have, and they carry a lot of information about their respective colors, right? Their position and their intensities. So for example, if we were to look at this first pixel that is called pixel A, right? And this position is actually 0 by 0, so which means 0th row and 0th column. So it has 255 intensity in the first channel, 0 intensity in the green channel, and 255 intensity at the last blue channel, which means that this little tiny box, or this little pixel, is going to represent some color which is a mixture of both red and blue, some intensity of red, maximum intensity of red actually, and maximum intensity of blue. So it's going to represent some color like that, a mixture of colors, but it is not going to have any component of the green channel that we have. So no intensity of green channel, it's only going to be red and the blue channel, right? So that is how colors are made actually in digital image. A color, these are like the basics of formation of digital image inside a computer. This is how colors are represented. Colors are nothing but a mixture of the R, G, and B intensities. So we can get any color from these three primary colors. That is why they're called primary colors. So for example, we have, take another example. If we have like 0 here, so we have this RC image which has 0 at this pixel, right? So it's 1 2 0 1 2 3 fourth position, and 0 1 2 3 4 also 0 here. But green has, let's say it has, oh sorry, the red channel has 0 1 2 3 4. This one has the maximum 255 intensity, right? This box is going to represent a red color because The rest of the components are 0, right? As we saw here, it's 0. This one's green is 0 as well, and 255 for red. So each channel, each each band, each band is going to emphasize its own color on the final image that we see on our computers, right? Say for example, it's a man, like, right? And if he has like black hair at this position, if he has black hair, all of these values will be 0, like 0 and 0, 0. Wherever we have hair, all the values will be 0 there to represent black. So each channel is emphasizing their own pixel values onto the final digital image, and the RGB image is nothing but a concatenation of the 3 channels that are stacked on top of one another. There are also other images that have multiple channels on them. They are called high spectral images. They have like RGB, and then they have the ultraviolet information about those bands, and then the electromagnetic information about those bands. So all in all of them are stacked together. This particularly happens in a geospatial data, right? So data collected from satellites will have this extra bit of information, and they are called hyperspectral images. Hyperspectral images. They have a lot of bands other than R, G, and B. So that was about the all the RGB images, color images, digital images, how they represent colors in the digital world. And now we'll have a look, and in the next slide we'll look at how a camera captures these bands separately. So that is quite interesting. Meet you in the next video.